Hi students, this is TSR. Today we are going to discuss about one more extraordinarily important topic from polynomials based on exercise 3.2 concept, that is geometrical meaning of zeros of polynomial for bits and 1 mark 2 marks and graphical representation, which is very important for 6 marks. Okay, you will enjoy the class really. So extraordinarily important concept nana, damn sure question in this graphical representation for 6 mark long answers. So let's enjoy the class. Before that, whomever are encouraging us with their suggestions, with their comments, likes and their cooperation, thanks to everybody. Just please try to share this knowledge, right Nana? That important concept is geometrical meaning of zeros of polynomial. In the earlier exercise concept, we learned how to check whether the given numbers are zeros of the polynomial or not. Today we are going to learn about their geometrical meaning. It is very simple and easy concept Nana. You can understand it very easily. Just listen. What is that one? Geometrical meaning means graphical representation. In the Cartesian system, what is the meaning of zero of the polynomial? That is, every polynomial will represent a curve like a straight line, like parabola, or like this. Every polynomial will represent a curve. Okay, this curve gives us zeros in its geometrical representation when it intersects the x-axis. That is the important point. When the curve means polynomial intersecting, when it is intersecting x-axis, that intersecting points x coordinate is the zero of the polynomial. That's it. Once again I am explaining. If the curve or polynomial, when it is intersecting the x-axis, you will get an intersecting point like x comma y, ordered pair x comma y. Exactly it will become ordered pair x comma 0, because y will become 0 on the x-axis, that's why. Okay, in this whatever the x coordinate is there, that is the 0 of the polynomial in the geometrical meaning. Understood? One simple and easy example I will explain. Here you please see. Let us suppose p of x equal to 5x plus 2. It is a polynomial with degree 1. Okay Nana? That's why it is called linear polynomial. It is a linear polynomial. So linear polynomial whose degree is 1 always represents line, always represents a straight line graphically. Remember that one. So it will come like this. In the Cartesian system, when you have x-axis and y-axis with origin, it will represent a straight line and which is intersecting the x-axis, which is intersecting the x-axis. Okay Nana? Like that. It may intersect somewhere else. This is the x-axis. Now you can extend it. The straight line intersect the x-axis. Maybe here it can intersect, here it can intersect, like this, like this, like this. We don't know where it will be, but it will intersect. That intersecting point is comes like ordered pair x comma 0. That x coordinate is the 0 of this polynomial. You know how much that one is? Let us suppose 0 means what? The variable value which makes the polynomial 0. So take the polynomial as 0 as a rough work. 5x plus 2 equal to 0 you suppose. Automatically 5x equal to minus 2, therefore x equal to minus 2 by 5. Okay na? So this one represents a straight line in the Cartesian system intersecting the x-axis at a point ordered pair minus 2 by 5 comma 0, minus 2 by 5 comma 0. The curve where it intersects the x-axis gives 0 with its x coordinate. That's it, Nana. So one more simple example I would like to give you. If p of x equal to 2x minus 7, okay, it is a linear equation representing a straight line. By changing different type of x values, you will get different type of p of x values which are called as y values. This will be taken as y. For different type of x values, you will get different type of y values. If you plot all those points, you will get a straight line. Automatically, by the extension, it will intersect the x-axis somewhere else. You know where that it will be? Let us consider this polynomial equal to 0. Automatically, you will get variable value 2x equal to 7. That implies x equal to 7 by 2. Therefore, ordered pair 7 by 2 comma 0 is the x-axis intersecting point. Did you understand, Nana? This concept is important for bits and 1 mark only. That's why I am telling fastly. So, in graph, in the Cartesian system, it is going to intersect like this, straight line intersecting the x-axis at a point. That one is 7 by 2 comma 0, because on the x-axis y coordinate is always 0. Is that clear, Anna? Like that. What is the generalization of this concept? If p of x equal to ax plus b at a not equal to 0, highest power of the variable coefficient should not be 0, okay, then it is representing a linear expression, okay. It represents a line, its x-axis intersecting point. If p of x equal to ax plus b at a not equal to 0, then its x-axis intersecting point is ordered pair minus b by a comma 0, minus b by a comma 0. How we will get it? Take this total expression equal to 0, like this, you will get x value, okay. That x value is called x coordinate. Y is automatically 0 because this is equal to y, which is the polynomial, Nana, which is the polynomial. We are making that y equal to 0, y equal to 0 automatically, then only x is coming, okay. This is the important point for bits, Nana. Remember that one, okay. Okay, Nana. After that simple concept, what is the graphical representation of quadratic polynomial? Quadratic polynomial, because linear polynomial graphical representation I explained and I had given some examples. Quadratic polynomial means, what is the general expression of quadratic polynomial, Anna? P of x equal to ax square plus bx plus c, where a not equal to 0, it always represents a quadratic polynomial, quadratic expression, okay. It always represents a parabolic shape. Remember that one, Anna. Important for bits. It always represents a parabola. Its graphical representation is a parabola. Parabola means what is that? Exactly U shape. U shape is not your shape. English alphabet capital U shape is there, na? This one. Okay. This is called open upwards parabola. Another condition also there. That one is like this. Reverse U shape. This is called open downwards parabola. Regarding this graphical representation of quadratic polynomial, there is a lot of concept, Nana, but for the public examination point of view, only few things are important. That one is when the parabola will be open upwards, when the parabola will be open downwards, and what types are there to generate the zeros. That only important. I will explain just in 2 minutes. Listen to me. In this, at x square coefficient a is greater than 0, means when x square coefficient is positive, automatically parabola is open upwards. Open upwards means like this it will be there, U shape, alphabet U shape. And another one is at x square coefficient a is less than 0, negative, then it is open downwards. Open downwards. That means reverse U shape, this one. These 2 points are very important for bits. Simple example, if p of x equal to 2x square plus 5x plus 3, here x square coefficient is positive, a equal to 2 which is greater than 0, therefore it always represents open upwards parabola. Okay, Nana, remember that one, U shape. Whereas p of x equal to 3x minus 4x square plus 1, in this you see polynomial is there, but it is not in the order. First you rewrite this one in the proper order, then this will be equal to minus 4x square, highest power of the variable should be in the beginning because that represents the degree of the polynomial. So write it in the order, that is safe for us. Minus 4x square plus 3x plus 1 is the proper order. In this, x square is the highest power of the variable, degree 2, quadratic polynomial. So its coefficient is minus 4. Here a equal to minus 4 which is less than 0. Therefore, parabola is open downwards. Open downwards. Understood, Nana? Like this also you can write. So this is the shape. These are the simple examples. Okay. Next, what concept is there? This parabola, it may be open upwards or open downwards. It is a parabola. Quadratic polynomial always represents a parabola. What types are there according to 10th class syllabus? Just observe this one, Nana. Simple point, very important for examination point of view. So different types. First type, Nana, parabola may be in the Cartesian system, may be intersecting the x-axis at 2 points. Parabola can represent the x-axis at 2 points, or like this, or like this, okay, or like this. In all these, parabola intersecting the x-axis at 2 points, here and here, here and here. Okay, na? This is one category. In this category, what do we observe? The parabola will be having 2 different intersecting points. So 2 different x coordinates will be there. So that 2 different zeros you will get. Understood, Nana? 2 different zeros are possible. Understood? Like ordered pair 2, 0, 5, 0, like that. If you got the intersecting point, 2 and 5 are zeros. 2 and 5 are zeros. Understood, Nana? Like that. Second type, in the Cartesian system, if the parabola is touching the x-axis, it is touching the x-axis at one point, this model, or like this, intersecting at one point, parabola. This one also parabola. This one also parabola. Is it clear? In all these cases, the parabola, quadratic polynomial graphical representation, intersecting the x-axis at a point. Okay, na? So that point x coordinate is the 0. One intersecting point you will get. Okay. So if it is ordered pair a, 0, then the zeros are a comma a, repeated zeros you will get, repeated zeros you will get. That's why at most n zeros will be there for the nth degree polynomial. Okay, so here you will get only one intersecting point only, like this. But what is the another degree 2, another 0, that will be repeated. Okay, for example, if the polynomial is intersecting at 4 comma 0, then the zeros will be 4 comma 4, repeated zeros. Understood, Nana? And the third point is, third model graph, if the parabola is not intersecting or touching the x-axis. Here who is the main point, Nana? X-axis. Intersection is main thing we have to observe. So in all the cases, x-axis intersecting points, x-axis touching points, x-axis was only main observer here. So here parabola is not having any relation with x-axis, it is away from the x-axis. Okay, like this or like this. In different models will be there. In this, parabola is not having any relation with x-axis, so it is having no zeros, no real zeros, no zeros, Nana. Understood? So keep that one, very important for bits, right? Okay, Nana. Based on that concept, we entered into exercise 3.2. Most important problems only I am taking, Nana. In second bit, second, fourth question. In third bit, first question, fourth question I am taking. Okay, na? These are important for 1 mark, 2 marks. This is a damn sure 6 marks question, long answer. One problem only I am explaining. Learn that one perfectly. That model numerical changes questions we have to practice. Fourth one is important for 2 marks bits. Okay. First bit is regarding graphical representations, Nana. In that you just count how many times the curve is intersecting the x-axis. If it is intersecting the x-axis 3 times, 3 zeros will be there. If it is intersecting the x-axis, which axis, Nana? X-axis only. Y-axis is unnecessary for us, not countable, y-axis intersecting point. If it is curve is intersecting the x-axis at 2 times, 2 zeros will be there. If it is touching the x-axis at 1 time, therefore it is having 1 0. If the curve is not touching or intersecting the x-axis, moving away from the x-axis, no real zeros will be there. That is the very simple, important for bits, Nana. They will ask you. Okay. Next, second bit, second and fourth question. What is that second bit? Okay. The question is find the zeros of the given polynomial. Among them we have taken second and fourth question. Second one is the polynomial is p of x equal to x square plus 5x plus 6. Fourth question is p of x equal to x power 4 minus 16. Okay, Nana? How do we do? Solution, Nana. Algebraic method we are applying for finding the zeros. Okay. Given p of x equal to x square plus 5x plus 6. Let p of x equal to 0. To find out the 0, make the polynomial equal to 0. That is the point. Take the polynomial equal to 0 or make the polynomial equal to 0. Whatever the variables we will get, those are the zeros. So that implies p of x equal to 0 means this total value x square plus 5x plus 6 equal to 0. So how can we find out these possible x values? Different methods are there. In the first exercise, substitution of different type of variable values we have taken. Okay, na? That is called trial and error method, substitution method. Another one, factorization is there. We learned it in 9th class. Okay. Another one, quadratic formula will be there. That formula will come in quadratic equations chapter in 10th class. So let me apply factorization method. Okay. So factorization method is also called as splitting the middle term. So we have to split this middle term because already it is in the order, Nana. x square term degree 2, okay, highest power of the variable 2, next x power 1 constant. Order must be there to make the problem easily. Now factorization means splitting the middle term. To split this middle term into two terms, we need two new values. Two new values we want. What kind of new values we want? If you add those two new values, you will get x coefficient, middle coefficient 5. Sum of those two numbers must be equal to x coefficient 5. Next, product of those same two numbers should be equal to product of the extremes, extreme coefficients 1 into 6. 1 into 6 means it should be equal to 6. Such kind of two new values we have to predict. So what are they? According to the possibility, you have to practice very much for them. So 2, 3, if you have taken 2 plus 3 is 5, same numbers 2 into 3 is 6, okay na? So with the help of these two new numbers, you can split the middle term to factorize, okay. That implies write x square as it is. In place of 5x, you can write 2x 3x plus 2x positive value plus 3x, two terms are resolved, plus 6 as usual equal to 0. This one is the rough work, you have to show it to the evaluator, okay, for our benefit. Now what you have to do? 3 terms are becoming 4 terms. Now from first 2 terms, take whatever the possibility will come as common. From these two you can take x common, then the remaining value here x plus here 2, correct Anna? From the remaining 2 terms also you have to take whatever the possibility will come common, but remember that one, along with the sign you have to take it. If you are taking positive value, plus 2 plus 3 plus 7, like that with symbol you have to write. If you are taking negative value common, minus 3 minus 5 minus 7, like that you have to take common. So just observe this, plus 3x plus 6 equal to 0 is there. From these two we can take 3 common. 3 common means you should not write 3 like this, it is plus 3, then only connectivity will be there from term to term, understood Nana? Plus 3 is taking common. If plus 3 comes common, remaining value x plus 2 equal to 0. Clear? That's it. That implies next step. Now this total is one term, this total is next term. From these two, what possibility can be taken common? X into x plus 2 plus 3 into x plus 2 equal to 0 means x plus 2 is common, okay. So it is right side of the term. So simple thing, you can take it left side or right side. So it is going to common in the right side. X plus 2 is coming common. So what are the remaining values? Here x plus 3, understood Nana? Remaining value into common value x plus 2 equal to how much? 0. Product of two terms equal to 0 means either the first term equal to 0 or the second term equal to 0. Clear? Therefore x is equal to minus 3 or from this x is equal to minus 2. Okay Nana? Therefore conclusion, minus 3 comma minus 2 are the zeros, that's it, of this polynomial. Understood? Fourth question. In this given polynomial is p of x equal to x power 4 minus 16. Okay na? We can write this one as x square whole square minus 4 square. Okay Nana? It look like a square minus b square. Okay. So what is a square minus b square identity? that is equal to a plus b into a minus b. Clear Nana? In this bracket is a, this bracket is b, so a plus b means x square plus 4 into x square minus 4. Okay Nana? Now this is equal to x square plus 4 as it is, and again you can rewrite this one as x square minus 2 square. Am I clear? We have a possibility. Again it look like a square minus b square, which is equal to a plus b into a minus b. In this case, a means x value, b means 2 value. So this is x plus 2 into x minus 2 by this condition. Already this one is there, write it as it is, x square plus 4. So this is the given polynomial, resolved like this as factors. Okay. So to find out the zeros, let p of x equal to 0. Automatically this implies x square plus 4 into x plus 2 into x minus 2 equal to 0. Clear? P of x equal to 0. If product of any numbers equal to 0, either the first term equal to 0 or second term equal to 0 or third term equal to 0 are the possibilities. So this implies x square plus 4 equal to 0 or x plus 2 equal to 0 or x minus 2 equal to 0. Is that clear Nana? So this implies x square equal to minus 4. But square of any number is never negative. Square of any number is never negative. It will never become negative. So this condition is not exist. This condition will not exist. You have to remember that one Nana. Square is never negative. It is either 0 or positive, like modulus condition. It is either 0 or positive, greater than or equal to 0 only. Keep it in mind. So this will not exist. Now come to this. X plus 2 equal to 0 means this implies x equal to minus 2. Okay. Therefore x equal to minus 2 is 1 0 we are getting, one variable value. From this implies x equal to 2. Therefore x equal to 2 is the second 0. Therefore means concluding. Finally, what are the possible zeros of the given polynomials? Here condition not exist. From this minus 2 comma 2 are the zeros. Okay Nana, that's it.